All right, well, hello everyone, and welcome back. In this video, we're going to introduce overloaded operators in C++. So here's our goals for today's video. First, we will briefly review classes, abstract data types, and constructors from our previous video. If you haven't already done so, please make sure that you have reviewed our previous two videos on classes. This video continues where the previous videos left off. Our new topic for today is applying what we know about functions and objects to create what's called an overloaded operator using our classes. Let's briefly review what we learned about abstract data types in our previous video. You'll remember, we call a data type an abstract data type if the programmers using that data type do not have access to the details of how the values and operations are implemented. Remember, when we say abstract here, we are not referring to abstract art that you would see in a museum. Instead, we are referring to the idea of abstracting away the details or hiding the details of how that data type works. And we're actually able to produce abstract data types using classes. Specifically, being able to designate some members of our class as public and other members of our class as private. This allows us to selectively hide or share different details about these objects that we create. So here's the procedure for actually creating an abstract data type. It's actually fairly straightforward. The first thing you want to do is make all member variables private. Remember, we want to abstract away the details of how our data type works. In the second step, we create what's called an ADT interface. This interface contains everything a programmer needs to know in order to use your abstract data type. So this is all the information that you would provide to your coworker, team member, or classmate in order for them to know enough to use your program. This includes providing access to public functions, such as getters and setters, and also including those precondition and postcondition comments that explain what the functions do. Finally, in order to actually hide away the details, we place our function definitions in a separate implementation file. Remember, this implementation is required for the program to run because this is where all the function definitions are. But this is where we hide away all the details of how our program works. So the function definitions for all of our public and private functions are put there. And also we could have private members of the class stored there if we chose. So the idea here is we create a public-facing interface that anybody can access, and then we keep all the implementation, all the hidden internal details separate. In our previous video, we discussed how this was actually incredibly helpful for programming. Often you'll be writing programs as part of a larger team, and you'll need to be able to divide and conquer the programming tasks. By using abstract data types, you can keep a public interface constant while making changes and updates to the internal workings of your program. So abstract data types are an incredibly powerful tool that's very useful, especially when working on complex programs with a large team. In our previous video, we also introduced this idea of a constructor. We learned that a constructor is a member function that is just used to initialize our objects. We call it a constructor because it's literally used to make more objects from our class. And you'll remember that constructors are basically just member functions. All they do is initialize variables. So if you see a constructor on an exam, or if you're asked to write one on an assignment, you should be happy. Because what that means is that you just need to write a function that will initialize your variables and initialize your object to some desired setting. The important thing to remember with constructors is that they do have some special rules. For example, we know that constructors are called slightly differently. They're actually called when you declare an object of that class. Also remember, the name of the constructor is always going to be the same name as the class name. So whenever you write a constructor, you have to give that function the same name as the name of your class. We also learned that constructors have no return type, and they're usually made public so that they can be readily used. We can also use overloading to declare different versions of a constructor. So depending on how many arguments were given and the type of those arguments, we can initialize our objects under a variety of conditions. Finally, we also learned about the importance of the default constructor. You'll remember that the default constructor is a constructor that does not take any arguments. We call it the default constructor because this is the constructor that is used to initialize our object when no arguments are given. Therefore, it's basically the default version of a constructor. For example, if we had a class called bank account, you can see that our default constructor for bank account would be written as the name bank account with empty parentheses, because the bank account default constructor takes no arguments. Notice here we decided to have our default constructor initialize private variables to 0. But the goal with the default constructor is to just initialize all our private variables to some known initial value. That way we're not working with objects that have uninitialized data. Finally, you'll remember we covered in our previous video that it's a good practice to always declare and initialize your default constructor. You should always have your default constructor update the private variables to some known value. So remember, if you forget to write the definition for your default constructor, then by default there will be an empty definition created which does nothing. So it's always a good practice to declare and define your default constructor so that you can actually use it. Let's do a quick practice before we move on. Here we are given this day of year class, and you can see that we have a variety of public functions that have been declared. And then we also have some private members, including a checkDate function and 2 private variables, month and day. Here we are asked to write a definition for the function day of year. If we look in our public declaration, we see that day of year is actually the default constructor. And here we're supposed to initialize our date to January 1st. So in this case, we want to write a definition for this day of year default constructor in order to make our date January 1st. So let's go ahead and write a definition for this day of year default constructor so that we initialize our date to January 1st. So we have our declaration already in the class declaration. So the definition would be written in the implementation file. So we would write the definition for our day of year class in the implementation file, dayofyear.cpp. And remember, just like any other function, we just follow our standard function definition rules. One important difference is that since day of year is a member of the day of year class, we do need to include the scope resolution operator. So our default constructor definition would look something like this. Then we just need to add code inside to initialize the desired variables. So which variables do we need to initialize here? Well, we want to set our date to be equal to January 1st. And remember that our default constructor is supposed to initialize our private variables. If we look under the private section of our class, we see that there is a private variable for month and a second private variable for day. So in order to initialize the date to January 1st, we must write month equals 1 and day equals 31. That will initialize the private variables month and day within our given object to be January 31st. So one thing to be careful of is some students accidentally go like this. Notice you do not want to include the int here. If you include int here, this is redeclaring local copies of month and day. We don't want to do this. Instead, we want to update the existing private variables in our object. So there's no need to redeclare your private variables in your constructor function. Instead, we just want to update the existing private variables month and day So notice we're not declaring anything here. We are just updating our private variables so that they are initialized to the desired value. Let's try one last constructor before we move on. Here we're being asked to write a definition for a second constructor, day of year. Notice this constructor takes two arguments. So this constructor is not the default constructor. The idea here is that if we were to declare a day of year object, such as day of year today, and if we gave it some value, say maybe if today was like December 31st, if I wrote day of year today 12,31, our idea here is that this other constructor would initialize the day of year object today to be day equals 31st and month equals 12. So you'll remember, sometimes it makes sense to have overloaded versions of your day of year constructor, depending on what you're trying to do in your program. In this case, being able to immediately initialize a day of year object with a single line of code, that can be pretty convenient. Let's go ahead and write this definition. So just like before, this would go in the implementation file. And just like before, we need to remember our scope resolution operator, because day of year is a member of the day of year class. But notice this time we do have two arguments. So remember, the purpose of this constructor is to initialize the private variables in our day of year object. So in this case, you can see from our precondition postcondition, we want to initialize the date according to the arguments. That means we want to set the private variable month to be equal to whatever value we gave in the arguments. And similarly, we would set day to be equal to the day, because those were the values passed in the arguments. That way, if we plugged in 12 and 31, we would be able to initialize the day and the month accordingly. So hopefully now you're starting to see that constructors are actually pretty easy to deal with once you understand them. Feel free to reach out if you have further questions on these. And if needed, check out our previous video for additional review. Let's now continue on to overloaded operators. Let's first start with another CodeSense question. Suppose we have that rectangle class from before. So you can see we have the private variables width and length. We have our public functions in order to set width, set length, get width, get length, and also get area. So the question here is, what will happen if I try to add two rectangle objects, box 1 and box 2? Will C++ be able to figure this out? Take a moment and think about it. Will we be able to add two box objects just like this? Well, let's go ahead and take a look in CLion, and let's see what happens if we try to do this. All right, so here we are in CLion, and you can see we've declared our rectangle objects, box 1, box 2, and sum. We've used our set functions to initialize everything. And here we are attempting to add sum equals box 1 plus box 2. But uh-oh. You see this angry red line under the plus operator? We're getting an error from CLion. Invalid operands to binary expression. Well, that's kind of weird. Let's try running this. Oh, and you can see it definitely failed. And here, we're getting an error. No match for operator plus. Operand types are rectangle and rectangle. So you might be wondering, well, what's going on here? Why isn't CLion adding those two rectangles? And the problem here is not that CLion is unable to add those box objects. It certainly could. However, it doesn't know how we want those boxes to be added. We need to tell CLion what it means to take box 1 and add it to box 2. What does it mean if we write box 1 plus box 2? Are we just going to add the width and length of box 2 to box 1's width and length? Or are we going to add the areas and then back calculate what the new dimensions are? We need to be able to tell CLion what does it mean to add two boxes together. We need to teach CLion what that plus operator is supposed to do when we give it box objects. So now we've seen what happens here. So it turns out that if we try to add these two box objects, box 1 plus box 2, we're going to see choice C. The program will not compile. And here's the reason why. Our compiler does not know how to use the plus and equal operator with objects of type rectangle. Remember, rectangle is a programmer-defined type. It's not an int or a double, it is a type that we created. So we need to tell the compiler what we want it to do when we ask it to add two rectangle objects. And the good news is there is something we can do to fix this. We use what's called operator overloading. We use operator overloading to tell the compiler what it needs to do if we try to use operators with our objects. So let's first briefly review, well, what is an operator? And how and why would we overload them? So first, what is an operator? It turns out that an operator is actually just a function. And the only difference between an operator like plus or minus or multiply and a function is that we just have different syntax for showing our arguments. Here's an example. Think about the plus operator. Remember, normally we use the plus operator for addition. But when we want to add numbers in C++, we don't write add num1, num2. Instead, we would write num1 plus num2. So the plus operator is still a function in C++, but the syntax is just a little bit different in how we show our arguments. Because operators are functions, it turns out that we can overload the plus operator just like we can do with other functions. Remember, when we say overloading, that means that we are writing different versions of the function with the same name. So in this case, we can write a version of the plus operator that works specifically with rectangle objects. So remember, objects are programmer-defined data types. We create them, and we choose what goes inside them. So if we want C++ to know how to add, subtract, multiply, and divide our custom objects, we will have to tell C++ how to perform those operations with our objects. And so that's where overloaded operators come in. We have to write a new version of our mathematical operators in order for C++ to know how to do math with our objects. So here's how we do overloaded operators, or operator overloading. There's a few things to watch out for here. First thing to notice is that we can't just redefine these operators whenever we feel like it. We can only redefine our operators when using them with objects from a class. But it's actually very easy to write a new definition for an overloaded operator. The name of the function for the overloaded operator will always be the word operator, followed by the operator's symbol. So if we want to overload the plus operator, we write operator plus as the name of our overloaded plus operator function. Operator single equal would allow us to overload the assignment operator. Otherwise, when you're writing these overloaded operator functions, it's just like writing any other function definition. You just have to follow these important naming conventions. And there's also a few special rules you have to watch out for as well. But just like with any other function associated with your class, the declaration for that overloaded operator goes in the public part of our class, and the definition goes with our other member functions, typically in our implementation file. Let's now briefly review a few rules about overloaded operators, and then we'll do some examples. Please remember that the best way to get comfortable with these overloaded operators is to try practicing them yourself. The first few times you write programs with these, it might feel a little bit awkward and things might not make a lot of sense. Please make sure you give yourself the time to really understand these overloaded operators. They're really important for not only being able to work with objects and classes, but you'll see if you take more advanced programming courses that being able to overload an operator becomes increasingly important when your objects become complex and require more tasks. So here's some important rules to remember when overloading your operators. Remember, at least one argument of that overloaded operator must be a class type. We can't just write an overloaded operator for an int or a double. It has to be for an object of our class. So therefore, at least one argument of the overloaded operator must be a class type. Second rule is that an overloaded operator can be made a friend function of a class. Typically, it's not required, but often it's helpful. It just saves a little bit of code. Another important point is that new operators cannot be created. You can only overload existing operators. Another important point is that the number of arguments for an operator cannot be changed. For example, the plus plus operator is a unary operator which takes just one argument. So you're not allowed to overload the plus plus operator to take 10 arguments. If that operator normally takes just one argument, then your overloaded operator can also only take one argument. Another important rule is precedence. Notice the precedence of an operator also cannot be changed. So even if you overload an add or subtract operator, it still is going to have lower precedence than multiply and divide. Finally, our last rule. Notice there are some operators that cannot be overloaded. We won't really get into those details for this course, but it's good to be aware of in case you take any more advanced programming courses. Remember, not all operators can be overloaded. For the purpose of our class, I expect you to understand how to overload the basic operators, such as plus, minus, multiply, single equal, and double equal. I'm not going to ask you to overload anything crazy, but you can certainly overload some more advanced operators as well, if you ever have the need. So let's now go through a demo showing how overloaded operators can help us overcome that problem we saw in the rectangle class. You remember we were trying to add two box objects together. We wanted to basically take box 1 and box 2, both of rectangle type, and perform addition. So in order to do that, we can try declaring and defining some overloaded operators. In this demo, we will go ahead and write definitions for 3 overloaded operators. We will write a definition for the plus operator, assignment operator, and our equality operator. And remember, overloading operators might sound scary, but really all we're doing is writing a function that either adds stuff, sets one thing equal to another, or compares things. So remember, at the end of the day, we're just writing a slightly special function to perform a given task. Let's go ahead and give this a try in CLion and see if we can overcome that error that we saw earlier. Alright, so here we are inside our rectangle class, and you can see that I went ahead and I added the declarations for 3 overloaded operators, as we discussed. So first, I have declared the overloaded plus operator, and you see that the name of that overloaded plus operator must be operator plus. And notice what the operator plus does. The plus operator takes an argument, in this case we're calling it rect to add, and here we have set up the plus operator so that it will add the width of rect to add to the current object, and it will add the length of rect to add to whatever object we're using the plus operator on. We also have a declaration for the assignment operator, and you'll notice this one's actually returning a reference to the rectangle to equal object. And notice that in this case, we are using pass by reference here. The reason we're using pass by reference for this rect to equal is there could be situations where rect to equal contains a ton of data. And rather than making a copy of something that might be a ton of data, we can instead pass in a reference. That way we don't need to make a copy of rect to equal. We just refer to it, and we use it to perform our equal operation. Finally, our last overloaded operator is the equality operator, or double equal. And we see here that this operator, since it's equality operator, it is a bool type function. Remember, bool functions return a true or a false. So the double equal operator will return true if my rectangle is equal to rectangle to compare. And if I'm not equal, if my values are not the same, then I will return false. So now we have our declarations, but you'll notice that we have not yet put these in our implementation file. So let's go ahead and have CLion help us out a little bit. We can click Generate, and let's have CLion generate some definitions for us. Remember, if I right-click on these functions and I ask CLion to generate definitions, CLion will automatically write the empty function definitions for us in our implementation file. So I'm going to click OK, and you'll notice that CLion gave me some empty definitions. Now I just need to fill these in with whatever code I need in order to complete my tasks. So let's first start with the add operator. And sometimes when writing these definitions, it's helpful to refer back to our preconditions and postconditions. So I'm going to go ahead and just temporarily put my preconditions and postconditions inside so I know what I need to do. So notice that my plus operator is passing in some rectangle named rect2add, and this rectangle add operator needs to return a rectangle object with rect2add's width added to its own width and rect2add's length added to its own length. So we know that we need to return some value. I'll call it some rectangle. So that means we will need to declare a dummy rectangle object to hold the sum. That way we can hold the sum that we're calculating and then return it when our add operator has finished. So I'm going to go ahead and declare that sum rectangle object. This is going to hold the sum that I calculate. So now we just need to perform our addition. And in this case, we want to initialize some rectangle's values to be the sum of our current object's width plus rect2add's width. So in this case, I need to go like this. So notice what's happening in this first line. Sum rectangle.width equals width plus rect2add.width. This is going to take my current object width and rect2add's width. So here, I'm taking whatever my current object is that I called the plus operator on. I'm adding rect2add's width, and then this sum is being stored in the width of some rectangle. I need to do a similar approach for length. So notice here, I'm going to add the length from the current object and rect2add's length. And I'm once again going to store the result in sum rectangle.length. So notice what this does. I declared some dummy rectangle to hold the sum. I calculate the sum of my widths and lengths and store it in sum rectangle's width and length. And then when I'm done adding, I return this dummy rectangle with the values added together. So with that, we have successfully defined our overloaded plus operator. Let's briefly explain our other overloaded operators. Next is our overloaded assignment operator. You'll notice that this operator actually has a return type of rectangle ampersand. The reason for this is something you'll learn about in more advanced programming courses. But the short version here is that we actually want to return a reference to a rectangle. We need to return a reference so that the equal operator will work properly. So in this case, we need to return that reference, and so we need to go ahead and write our code in here in order to perform that reference operation. So let's remind ourselves what the equal operator needs to do. If we look in our preconditions and postconditions, let's go ahead and see what we need to do. So we know rect to equal is the object that we want to assign our values to. And our postcondition is that we are returning a rectangle object where the width is set equal to rect to equals width, and the length is set equal to rect to equals length. And notice here we choose to use pass by reference in case this rect to equal is a really big piece of data. So basically, in order to make this equal operator work, we just need to make the current object's width and length the same as rect to equals. And then return a reference to the current object. Let's briefly explain how to do this here, and we'll go through it in a bit more detail a little later. So first, how would we make the current object's width and length to be the same as rect to equals? Well, that's actually pretty straightforward. To access the current object's width and length, we can just take our width and say we could set it equal to something. But in this case, we want our width to be the same as rect to equals width. And we want our length to be the same as rect to equals length. So notice this is going to update our current rectangle such that its values, width and length, match rect to equals values. Finally, we'll talk a little bit more about this in just a moment. But notice that the rectangle equal operator must return a reference to the current object. So in this case, we're actually going to return this pointer named this. We'll explain more why this is later. For now, just know this is a pointer that automatically points at our object that operator equal was called on. So here, if we return asterisk this, we are returning a reference to our current object. This is everything you need to know about the overloaded single equal or assignment operator in this course. But there's a lot of small details and nuances that you may learn more about in future programming classes. Let's finally finish with our last overloaded operator that we want to write. Our last overloaded operator is the equality operator, or double equal. Let's remind ourselves, what do we want double equal to do? I'm just going to temporarily paste my preconditions and postconditions in here so that I can make sure I write this function correctly. Notice that my goal here is to compare my current rectangle object with rect to compare. And so if my width and length are the same in my current object and in rect to compare, then I return true. Otherwise, I return false. So there's a few ways that we could write this program. We could do something with if statements and say if width equals rect to compare dot width, and length double equals rect to compare dot length. So we could do something like this, where if I see that my width and length are the same between those two objects, I return true, then return false. But actually, the experienced programmer way of writing this is to, instead of using these if statements, we just do a return. Like this. And we remember our semicolon, of course. Remember that the double equal operator is already going to return us a true or a false. So it's still correct to use those if statements, but you'll see that experienced programmers will actually write the overloaded double equal operator, in this case, just with a single line of code. You want to be a little bit careful here, because if your object contained arrays or something more complex, you would not be able to fit the overloaded double equal operator on a single line. But because our rectangle just has two variables to compare, this is a very simple function that can be written with just one line. So there you have it. We have now successfully declared and defined all of these overloaded operators for our rectangle object. And now, if we go back into our main function, notice that that plus operator no longer has angry red lines underneath it. Let's go ahead and try running this program now that we have correctly declared and defined our overloaded operators. And we go ahead and click run, and look what we get. Here we have set box 1 and box 2 both to have width and length of 1 and 2. And remember, we declared our overloaded sum operator to add the widths and the lengths together. And we can see that is indeed exactly what happened. When we said rectangle 1, or when we said box 1 plus box 2 equals sum, we actually took our width from 1, width from box 2, and added them together. Our length from box 1 and length from box 2 were also added together. And then we see that our double equal operator also worked. And we were able to correctly determine that box 1 and box 2 are equal. So once again, hopefully now you see that overloaded operators are not too bad to deal with once you understand how they work. At the end of the day, they're just functions. So you just need to pay very close attention to what it is you want those overloaded operators to do, and make sure you follow the small rules about naming and syntax in order to correctly write the definitions. I highly recommend that you go back through this example on your own and verify that you're able to get the same result as I did. It's really great practice. Alright, so there's a few more things that we should cover about overloaded operators. First thing to note is that you can overload most operators in C++, other than the exceptions that we mentioned earlier. So if you wanted to, you could overload plus plus, minus minus, insertion extraction, and even the square brackets. So you should know that it is possible to overload these more advanced operators. But please note that I'm not going to ask you about these advanced operators because the implementation is more complex and beyond the scope of this introductory course. However, those operators do allow us to create some unique types of objects and classes. For example, if we overload the square brackets, we can create objects that behave like arrays. So there's lots of fun things you can do with these in more advanced courses. For the purposes of our class, please make sure you understand how you can overload plus, minus, multiply, divide, single equal, and double equal. These are the operators that I expect you to know for the purposes of this course. You'll also remember that when writing the overloaded assignment operator, we used this thing called the this pointer. Let's briefly talk a little bit more about what that is. It turns out that whenever you work on a member function of a class, the this pointer is always predefined. The this pointer always points to the object that function was being called on. So the this pointer is used to reference the current object that the function or overloaded operator is being used on. For example, suppose I wrote the code sum equals box1 plus box2. Inside this overloaded equal operator function, the this pointer would point to sum because essentially what we're doing here is we're saying sum dot operator equal, and we're calling operator equal on that sum. So the this pointer will always point at the current instance of the object that function is being used on. Here's another example of the this pointer. Suppose that I was calling the function getLength on box2. So in this case, the this pointer will be pointing at box2 because box2 is the object that getLength is being called on. So there's one other thing that is good to know about overloaded operators. Remember that operators are basically functions that just have a slightly different way of inputting the arguments. For example, here, if I wanted to set object1 equal to object2, I could write object1 equals object2. This is what we typically do. But if we wanted to, we could have also written object1 dot operator equal and then put object2 as the argument. Or I could say, instead of sum equals box1 plus box2, I could say sum equals box1 dot operator plus box2. So that is the actual true syntax that is being used when we're calling these overloaded operators. But operators also accept the kind of more typical syntax that we're used to typing for math. So finally, just an FYI, there's a couple things that are nice to know about other kinds of operators. I'm not going to expect you to know this on exams, but these are sometimes nice things to know about in case you need to write more advanced programs. So notice that the plus plus minus minus operators, depending on whether you're having them as prefix or postfix, you would overload them differently. Greater than, less than, equal to, those would always return a bool value. And if you overload any stream operators, they would need to return a reference to some sort of stream object, and also accept stream objects as arguments. Finally, if you ever needed to write an overloaded square brackets, notice that that can be used to create classes that behave like arrays. But notice that it returns a reference to a location in the object and not the object itself. Let's go ahead and do one more demo and CODiSense question before we end for today. Suppose we have a slightly more advanced class. Here we have this class called intArrayList, and what this class has is it has a 1D dynamic array. So notice this int values pointer here, this points at a 1D dynamic array. And then number of values is the number of values in the array. So here's kind of a picture of what that intArrayList class would look like. We would have, this, say we had an object named ArrayList1, and we see that it has a pointer named intValues that points at a 1D dynamic array. And in this case, we have 10 values. And so our question's asking us, suppose we declare these two intArrayList objects, ArrayList1 and ArrayList2. The question's asking, what happens if I run the code ArrayList1 equals ArrayList2? Well, let's think about this for a moment. The problem here is, what if that object contains a pointer? Remember, intValues is a pointer. And so if I set ArrayList1 equal to ArrayList2, notice that that could make my pointers point at the same memory address. And we do not necessarily want our pointers within different objects to point at the same location. This could create some pretty serious errors if we're trying to build a data structure or contain important data in these objects. So if we were to set ArrayList1 equal to ArrayList2, we would get the result like this. We would see that ArrayList1's intValues pointer would point at ArrayList2's intValues address. That's not what we want. Remember, we want each object's dynamic array to be located at a separate memory address. For example, in this picture you see, we probably wanted this output instead, where each object keeps its own private dynamic array. The only thing that happens is the values are set equal to each other within those arrays. So we want to prevent this error from happening. So whenever we have arrays and pointers, in our objects, We need to be very careful when setting the objects equal to each other. We need to avoid this potential error. Because the last thing we want to do is mess up our data if we accidentally make multiple pointers point at the same thing when they should be pointing to separate things. So that leads us to our last point for today, the copy constructor. So if you are working with objects that contain pointers, or even objects that contain dynamic arrays, you definitely want to make sure that you declare and define a copy constructor. So basically what a copy constructor does is it allows us to ensure that pointers from different objects aren't accidentally pointing at the same address. So the copy constructor is really important to make sure that each object's pointer stays pointing at a separate address, and we don't accidentally make things point to the same address when they're not supposed to. Copy constructors also help us in cases where someone might write object 1 equals object 2 equals object 3. So if we're in a situation where we have objects being set equal to each other multiple times like this, the copy constructor helps protect against certain errors that can pop up in these situations. So here's what a copy constructor does. A copy constructor will take the memory address of an object, and notice what it does. It's very similar to the assignment operator in that it will take our current object's values and make them equal to whatever's at the memory address. So it basically copies values from a memory address into the current object. So it's copying data from somewhere else into our current object, just like the equal operator. But here's where it's different. The copy constructor also includes code to ensure that any pointer memory addresses are kept unique. So we do not set pointers to point at the same address. We make sure pointers point at separate memory addresses. So let's go ahead and return to that int array list example, and let's look at how that copy constructor might look. So here's an example of how we could write the copy constructor for int array list. Notice that in this case we want to copy data from other into the current object. So here, notice that we set our current object's number of values to be the same as others. And we set the list name to be the same as others. But notice here, a dynamic array is still created at a separate memory address. So we do not say int values equals other dot int values. We do not have that code because we do not want to overwrite. We don't want to make our current object point at the same location where the other object is. We want to make sure each object's dynamic array is located at a completely separate address so that there is no mixing of our data. But notice once we have created that dynamic array, then we still copy the values. We just make sure that the dynamic array is located in a separate memory address. That way, we are not accidentally pointing at the same location. So let's go ahead and end with a little bit of practice. Let's try writing the default constructor, overloaded plus operator, and the copy constructor for our int_ArrayList class. So let's start with our default constructor. Here we are told that the default constructor should initialize our int_ArrayList object to have number of values equal to default, where default is some constant, list name is unnamed list, and all values are initialized to 0. This is actually a fairly straightforward function to write. So we would start out by writing our definition in the implementation file. And let's go ahead and write what our definition would look like. Since it's a default constructor, it does not have any return type, but it does need the scope resolution operator. And so, like usual, we just go ahead and put all our code inside the curly braces. So in this case, we go through and we update our private variables. So we say list name is unnamed list. We say number of values is default. So we're assuming default is some global constant that's been defined already. And now we need to initialize all our values to 0. So we need to create our 1D dynamic array. So we'll take our pointer int values, and we're going to make it point to a new 1D dynamic array. And remember, this will have number of values. Here we had already initialized number of values to be default. Our last step is to initialize all values in my int values dynamic array to 0. So to do that, we just use a for loop. And in this case, we'll just say int values element I is 0. So that's all there is to it. Remember, constructors are purely designed to initialize our objects. So here we have just initialized an int_ArrayList object to contain the default values that we had specified in our precondition and postcondition. Next is our overloaded plus operator. So in this case, you can see that we're trying to take list to add and add all the values such that each element in int values element I for our sum is going to contain the sum of the current objects and list to add's values. So let's go ahead and write our definition. Once again, this would go in the implementation file. All right, so we add in our header, and inside this function header, notice our goal is to return a int array list object that's the sum. So first we need to declare a dummy sum. I'm going to have a dummy object that I return. And I now need to initialize sum such that it contains the sum of the elements in int values plus list to add. We also want to make sure that sum contains the same data for list name and number of values as our current object. So we'll say sum.listName is equal to our current object's list name. We'll say that sum.number of values is equal to number of values. And then we need to declare our dynamic array. So we'll have sum.int values points to a new int with number of values. And then now we just need to use a for loop to sum each element. So in this case, we say sum.int values element I. We want that to be our current object's int values element I plus, in this case, we have list to add dot int values element I. So we'll see that this will allow us to create this new int array list object named sum. We initialize sum to contain the same values as our current object, but we update all the elements of its dynamic array to be the sum of our current object's values plus list to add's values. And finally, for the copy constructor, this one we already briefly introduced before. So as we mentioned before, the copy constructor takes the memory address of some other int array list object as its argument, and it copies the values located at that other memory address into our current object. However, it prevents us from accidentally copying over and duplicating that memory address where the dynamic array is. We include code to make sure our dynamic array is kept at a unique memory address. So here, all we need to do is copy others' values into our current object, but keeping the dynamic array address unique. So in this case, we can go ahead and start copying the values. So we want number of values in our current object to be equal to others' number of values. And also, we want our list name. We're going to copy others list name. So we're just copying all the data. And finally, remember, we have to keep our pointer at a separate address, so we're going to say int values is equal to a new dynamic array. So we're not going to copy the memory address where others int values is located. So notice, now that we have this, we can use a for loop to copy all the data into our dynamic array so that all of others' dynamic array data is the same as the data in our current object. So we'll use a for loop. And we'll simply say that int values element I, basically each element of our current object's int values array must contain the data stored in others int values element I. So you can see in this case, we have successfully copied all the data from others int array list into our current object int array list. However, we were very careful to ensure that our int values pointer still points at a unique address. Now that we've written those overloaded operators and copy constructor for int array list, let's briefly demonstrate the difference that happens before and after we implement those functions. So suppose I have this main function where I'm declaring int array list 1 and array list 2. And suppose I'm trying to set these two int array lists equal to each other. You'll see that I have some code here in order to set int array list 2 to hold the value 999. And then you'll notice that I also output that data to the screen. And so our goal here is to set array list 1 equal to array list 2. So here I attempt to use the equality operator, and then we output the values to the screen. Then I try to update array list 1's values equal to 10, but we'll see that if I have not properly set up my copy constructor and equality operator, then array list 1 and array list 2 will point at the same thing, and I will actually inadvertently modify both array lists' values when I run this code. Let's try running it so you can see what's happening here. So you can see what happened here is that I've declared two array list objects, and I've initialized them to have initial values. Then I set array list 1 equal to array list 2, but at this point in my program, I have not set up my copy constructor. And you'll see what happened is then, when I try to set array list 1 to another value, it will also accidentally change array list 2 because I have incorrectly made array list 1 and array list 2's pointers point at the same location. To fix this, I need to implement my copy constructor and correctly implement my equality operator as we illustrated in the example. So notice here I have correctly implemented our int array list copy constructor. Notice the reason why our int array list was not working properly is because we had directly copied the memory addresses between int values and our other list. Instead of having this code, we need to instead make int values point at a unique memory address. We'll see now if we rerun our program with our copy constructor and equality operator correctly declared and defined, we will see that updating ArrayList1 will only update ArrayList1, and ArrayList2 will not be affected. So you can see here, now that we have corrected that issue with our copy constructor, we see that ArrayList1 and ArrayList2 have their pointers pointing to separate memory addresses, and therefore any changes made to ArrayList1 do not accidentally affect ArrayList2. So key takeaway here, definitely be careful when writing your overloaded assignment operator and copy constructor, and make sure that any pointers and dynamic memory are always pointing to separate addresses. If you make pointers between objects point at the same location, then you could accidentally cause memory to be overwritten and accidentally corrupted later on. So there's a couple other points that are worth bringing up here. These become important in more advanced programming classes. There's this important rule called Rule of Three. And you'll learn if you're trying to design some data structures or more complex classes. The general rule is that if your class contains dynamic memory, so that's basically any variables created using pointers and the new operator, the Rule of Three says that you generally always need to declare and implement the following three functions. You need a copy constructor in order to accurately make copies of data from different locations. This ensures that you don't create any errors when copying data from one object to another. You want to make sure that your dynamic memory still points at unique addresses and that you're not accidentally making pointers point at the same location. You'll also need to declare and implement overloaded assignment operator and something called a destructor, which we'll cover more later on. The destructor is used to delete dynamic memory and delete objects when we're done using them. We call this the Rule of Three because these three functions are basically required in order to make sure that classes with dynamic memory can successfully initialize, manipulate, and delete objects in our programs. Last point for today is something called the copy and swap idiom. This is a more advanced thing that is not going to be covered in this course, but just giving you a heads up that sometimes if you're using the overloaded equal operator and copy constructor, there are some extreme edge cases where you might not return errors and get the results that you expect. And so sometimes in industry, people end up using a slightly different approach called the copy and swap idiom. So if you're starting to use the equality operator and copy constructor and you're running into edge cases, you may want to consider looking up the copy and swap idiom and using that in your programs. We're not going to cover it in this class, but you may see it in future programming courses. So let's go ahead and wrap up here for today. You should now be more comfortable declaring and using classes and being able to understand the importance of abstract data types and constructors. Please make sure you take the time to review the examples that we covered, and make sure you get comfortable using functions, objects, and overloaded operators in your classes. The first few times you work with these, it's going to feel awkward, but you'll find that with practice, they become a lot more intuitive. So feel free to reach out if you have any questions on this, and we'll see you in the next video.